Okay guys, so today we are going to look at some more chemical equations. So I'll just read through this for you guys here. So it says the law of conservation of mass. So we've talked about this quite a bit this week already. We talked about it with our Whack-A-Packs, and when we were looking at our equations on with our Captain Crunch that day, we kind of talked about this a little bit, how we know that mass is never created or destroyed. So the law of conservation of mass states that in a chemical reaction, the mass of the reactants, so remember the left side, my reactant side, equals the mass of the products. So this is talking about how much they weigh or their mass. It says that's because you cannot create nor destroy matter, because the law of conservation of mass, chemical equations that show chemical reactions must be balanced. This means they must have the same number of atoms of each element on each side of the arrow. So I'm going to write a few things on here just as a refresher. So remember, on the left side, these are called my reactants. And then I have my arrow. I'm going to underline those. And then I have my products. So these are my products. So I always like to say wrap whenever I'm talking about chemical equations. So just remember to wrap. You have your reactants, the arrow, and the products. And if you want, you can even put an equal sign, because that arrow means equals. So in this situation, I have H2, so hydrogen gas reacting with oxygen, which is a gas. Those react together to form H2O, which we know as water. That's my product. That's what they create. All right, and then so here it's saying that this is not balanced. So what we're doing for this worksheet today, we have H2. Okay, so that means I have two H's, so two atoms of hydrogen. And then I have O2, so that means I have two atoms of oxygen. Then on my product side, I have, again, H2, so that's two hydrogens. But I only have one oxygen. So just like when we looked at some of these equations when we were practicing with our Captain Crunch, we see that these are not balanced. So this makes us very sad. I told a few classes that it makes us sad because when you're in high school chemistry, you have to do lots of changes and multiplication to try to figure out how to make it balanced. So we're sad. On the right-hand side, this is showing an example of a balanced equation. And so let's look here. I've got my coefficient of 2 in front of my H2. So remember, we have to multiply. I'm going to write this out. We have to multiply 2 times 2 to give us 4. So this has to multiply by that. There's a plus sign here. So this O, this oxygen, is not affected by this coefficient. So this means I have 4 hydrogens here, so 2 times 2, and then I have 2 oxygens. On my product side, I've got another coefficient of a 2 in front of my H2. So again, that's 2 times 2, that equals 4 hydrogen atoms. This 2 is also applied to this O. So again, remember, I've got 2 molecules of H2O. So I would do 2 times 1, because remember, if there's no subscript, it's just 1. So in this case, I have 2 oxygen atoms. If I look from left to right, I have 4 H's here, and I end with 4 H's. I start with 2 O's, and I end with 2 O's. This is balanced, and it makes us oh so happy. All right, so now you guys are going to work through a few problems of your own. So it says we're going to count the number of atoms, and you're going to basically tell if it is balanced or not balanced. You can put a little smile or a little frown. All right, so if you are in my advanced classes, you probably will not see these on here. You can add them if you like. Let's see, what should I walk through? Anyone? Which one should I choose? I'll just randomly choose this one down here. So I'll just start right here. I'm going to walk through as an example. So I have N2, so this is nitrogen gas. So I have, and it's best to do this in pencil, guys. I'm doing it in this so you can see it easier. So I have 2 atoms of nitrogen, and then I need to figure out how many hydrogens. So 3 times 2. 3 times 2, because that's a coefficient. So I have 6 hydrogen atoms. On my product side, I've got this coefficient of 2 in front. So for my nitrogen, it's 2 times 1, giving me 2 nitrogen atoms. For my hydrogen, it has a subscript of 3. This coefficient is still connected to this hydrogen because there's no plus sign. So I have 2 times 3 for my hydrogen, which gives me 6. And I call this a 2-finger check. So I've got an N on my left, an N on my right. They're the same number, 2 and 2. That's equal, that's balanced. Hydrogen, a 6 on my reactants, a 6 on my products. That's balanced. So a nice big smiley face because that is indeed balanced. All right, and then we'll just go up top here. So I have sodium plus chlorine. So there's nothing here next to this Na. There's no coefficient, there's no subscript. So that means I have one atom of sodium. The same is true with chlorine. There's no coefficient, there's no subscript, that's just 1. Over here on my product side, I have a coefficient of 2 in the front. So this 2 goes with my Na. So 2 times 1 means that I have 2 sodium atoms. It goes with my chlorine, so 2 times 1 is 2 chlorine. If I do my 2-finger check, 1 and 2 are not the same number. So already I know it's unbalanced. The same goes for my chlorine, unbalanced. So again, we're gonna put a little frown, a sad face. That makes us so sad. All right, and so that's what you guys are gonna do for the rest of this. When you're finished, you can staple it into your notebook on the next page because it'll be checked, but it's gonna stay in your notebook.